Tech 120, and we are here to present the Martian Rover Multi-Tool.
Alright, my name is Brady Hawks. I am a freshman this year, and I am currently majoring in industrial design.
My name is Julie Krasinski. I am a sophomore this year, and I am majoring in game design.
My name is Drew Yoder, and I'm a freshman as well. I am majoring in aero engineering technology.
And then we have a fourth group member, John Walker, but he is not here with us at the moment. So we were all really inspired at the beginning of this project by the very recent landing of the Perseverance rover on Mars. And we all knew that we wanted to do something oriented around space and Mars specifically. So we had a few different ideas in mind that we started with. We liked the ideas about terraforming Mars. We looked at things about landing vertical rockets back and forth in the reusable rockets that they're currently working with. And also just the idea of, very soon having humans on Mars. And we had been working with a lot of these different ideas, and we began doing our research, focusing more so on the idea of creating a rover or a tool or an object that would help assist, be it clearing out a landing area or actually something that would, like fold out and land ahead of time for those reusable rockets to land on, to create a higher success rate for those landings. But the more research we did, we realized that it really wasn't a very serious problem or one that could be well solved. So how it was described to us basically is that with the constant changing conditions up there and the high winds and just the natural loose soil and terrain on Mars, it would kind of be like trying to clear a hockey rink in the middle of a snowstorm. And it just really wouldn't work too well, and by the time you finished, you'd have to start back over, and that landscape is just continuously moving. And we realized that we kind of had to move from that idea to something that was much more manageable for us. And so we moved to the next thing on our list that we all were really interested in, and that was the idea of having humans on Mars. And something that's definitely coming up and will be something that's going to have a lot of issues involved around it.
So with our research, we realized that the rover mainly focuses on exploration by driving around and recording footage of terrain or atmosphere and drilling core samples. And we also realized that the cost of sending people to Mars would be very expensive. It costs $6 billion for the first manned mission and $4 billion for every mission after that, and that's just not something that anyone can afford at the moment. So we realized the rover would be the better option. It costs $10,000 per pound to ship to space, and the rover would cost a lot less. It weighs a lot less than a rocket and all of the utilities with the rocket. And we also realized that the conditions on Mars, the rover can deal with them better. The extreme temperature fluctuation and the wind and dust storms and the static electricity.
So, as you can see, our POV statement is future Mars rovers need better tools for the construction of a human habitat on Mars because they currently have a narrow focus mainly on exploration. So we researched the tools that would be needed to prepare Mars and soil and whatnot for humans, and as you can see, here's the list of all the things we need. For our stakeholders, we mostly focused on both humans that would mainly require you show interest in what would be needed, and as well as future rovers, because we don't think it's possible to do it with current rovers, but it's very possible that we can attach the arm on a rover that will be made in the future.
And we started to look at those rovers, and we realized that with costs and everything in mind, and especially the costs of sending things to space, and just the scope of the project, the more people that we talked to, we realized that trying to create a whole new rover really wasn't that doable. So we shifted our ideas to, like what Julia was saying, creating a tool or an arm that could be used on future rovers for more of those construction things that you would kind of see here on Earth, but that will definitely be beneficial and useful for the preparation and for the actual construction of habitation and life on Mars. So we began to look at, okay, so what is here on Earth that we use everyday construction sites? We have things like claws that are used in cranes to move objects, whether it be remove dirt, rubble, to hold new objects, keep things in place when they're being constructed. And then we also looked at other current existing things in space. So right now, astronauts use a space hand drill when they go out on spacewalks, and it is, well tested and obviously something that works very well. And we wanted to see if there was a way that we could incorporate a lot of these different ideas into one tool and just really increase the functionality of these future rovers going up so that they can do the most for preparing for humans to be up there. We initially started with that idea that we just wanted to do as much as possible, and that, Swiss Army tool. And we were thinking, what were the different pieces we could include? What would we really benefit from as humans, but also that would realistically be something we could put into a tool that could be used, be it by autonomous control or robotic control for a robot. And we started with these very big concepts of just adding multiple things together, and we slowly moved forwards from there. We really realized the more in-depth our research got that a claw mechanism was something that was really important. So we focused on that to start and created something in Fusion 360 that allowed us to look at the movements of a claw in some of the different space that we had, and to best incorporate other tools around that claw mechanism, because something like that could be really useful to a rover. So the more we looked, we realized that the tools we wanted to add were, one, that claw mechanism, but then also something that we could use to move dirt and rocks and things out of the way, and then a drill. So be the drill for construction uses of actually building things or destroying, those different rocks and debris that may be around when you're trying to clear an area for future habitation. So the ideas we roughly came up with in the beginning were something that had this same claw mechanism idea to it, and then the actual sides of that claw itself were angled down towards the front, so as the claw was closed, it could be used like a shovel to move dirt and debris and those different rocks. And then the last portion that we wanted to include was that drill. And initially we mounted it up on the top, and the idea was to use it up there, and then, you could maybe hold something in place and then drill at it with the claws so that it would be even more secure. But as we got into it, we realized that would be more of an issue than like a cool feature. And we ended up actually changing that in our final design. So our final design, as you can see, is a much more slimmed down and simple mechanism, and mostly works around that main claw portion. So the main claw that you can see up here is definitely still the biggest piece of it, but now we have actually changed that drill portion from before inside that mechanism of the claw. So as the claw opens, that drill portion comes out and actually faces vertically and downwards, so that if the claw, that whole tool can be moved upwards, you now have that entire underside to work on whatever you may want. We also still kept that same slanted design in the front, so that as the claws are closed, you can use it like a shovel, and still increased all that functionality of being able to have such a big surface area for that claw to move things and hold things. So with Fusion 360, it made it really easy for us to actually, not with the little CAD experience that we had before going into something like this, create these different models and these different views that allowed us to work on these parts, see what really worked, what didn't, and kind of put these different mechanisms into play. And it was really nice for us to have a tool like this and to be able to work on stuff, especially as a team, because you can only do so much on paper, and sometimes it's really good and really necessary for us to visualize those ideas and see those mechanisms working together. And that's kind of how we got to where we are now. But moving forward, some things that we talked about wanting to do was the possible addition of vision systems to improve just that robotic and autonomous control for the robot, because it could make things that much more precise and just that much more usable. another thing we had talked about with the static electricity issues that they have. That issue isn't nearly as big for humans as it is for robots and electronics. And we were much more focused on proving our concept and proving that those mechanisms would work just to increase the functionality and have a tool that can be used. But realistically, you've got issues like dust, debris, and static electricity that would be needed kept out of those mechanisms. So creating some sort of housing or fancy space foil to be wrapped these different pieces in so that it could keep those things out and keep those mechanisms and tools working for as long as possible. And the last portion that we really wanted to try to accomplish, but unfortunately really didn't get into, was a bit changing mechanism that would work on our tool and the current claw design, so that you could use multiple different bits and have more uses and just really, take that functionality to another level. And we created a mechanism in Fusion 360 that worked with a couple different pieces, and that used that same portion that would be in that sliding piece of the claw as it would come forwards. So this would sit vertically and then would still hold those different bits as they changed in, and then another stepper motor that we would have on top would rotate those pieces around, and then as they came forwards, they would be locked down into that one position where those gears would mesh at the bottom. And then looking underneath, like the one bit design that we have now, it still gives you that usability of the entire underside of the tool for whatever you want to drill or work on. And then as you want a different bit, this piece just rotates and then locks in another piece, and then you can keep working from there. That's all.